Now we're going to get into the types of chemical reactions where we're actually making chemistry, we're putting things together. Now the first type is the combination or synthesis reaction. Your book calls it combination. I never really heard it combination. It is combination, but most people will call it synthesis reaction. So if you hear me call it synthesis or you see synthesis in other textbooks, it's what your book refers to as a combination. And that's just when you bring two things together and R, for example, plus an S, combine or synthesize, they make RS. It's like if we have a romantic couple here, a dreamy teen idol and a cool celeb, they come together. And what do they make? They're a couple. Isn't that romantic? So they become a couple. Real life example, if we have iron and sulfur, they make iron sulfide. They come together, they synthesize to make iron sulfide. Next type is a decomposition reaction. And that's, as you can see, we have a compound here and it breaks down into its individual entities. So that's just like if we have this happy couple and what happens? They break up. Very sad. They go on their way though. So it decomposes, it breaks down. Example, we have water breaking down into hydrogen gas and oxygen gas. Single replacement reaction is where we have one thing, such as a positive metal, replace the other positive element and makes a new compound. So you have to kick, one kicks the other out, and there it is. Such as in this example, we have this lovely couple. And then another dreamy teen idol comes along, and she whoa, look at he. And there we have a new couple. And poor Austin is out there on his own. Poor guy. An example here is we have magnesium come in, kick out the hydrogen, and now we have magnesium hydroxide, plus hydrogen gas. Now double replacement is where you have positives will switch place with each other and then the negatives will switch place with each other. Or the metals will switch place with each other and the nonmetals will switch place with each other. And we have new compounds formed. So for instance, if we have this couple, they meet another couple, they just switch partners. On Raven Simone there and Austin are back together. Isn't that romantic? They were always meant for each other. And then, of course, Mila Kunis and Brock Storm, true boyfriend, girlfriend. And there we go. And here we have, notice, the lead and the potassium, both positive, they will switch places. So the lead switch places with the potassium, or we can say the nitrite switched with the iodine. And so they just switch places. We have new compounds. Very, very interesting. Now the next one is a combustion reaction. When you hear of combustion, you think of burning. Combustion of a hydrocarbon. Now hydro means hydrogen. Carbon means carbon. So the general reaction here is any carbon and any hydrogen together as a carbohydrate. And when we burn something, what do we need? We need oxygen. So anytime you see an plus O2 in a chemical reaction, that means we're burning something. Because that's what you need. You need oxygen in order to burn. So if that should be a tip-off. If you see something plus O2, you're burning something, that's a combustion. Now when you combust a hydrocarbon, something with carbon and hydrogen, you're going to get these two things, water and carbon dioxide. And this is actually a very easy one to predict, because anytime you're burning a carbohydrate, you're going to get water and carbon dioxide. An example is, here's a carbohydrate. We burn it, and we're getting carbon dioxide and water out. If you guys remember, there's something called a C6H12O6. Remember this from biology? And we have oxygen. And what do we get? Carbon dioxide. And I'm not going to balance this right now. And water. Remember that? That's combustion. That's respiration, cellular respiration. You're using that oxygen as the last electron acceptor. Breathe out carbon dioxide and water. Now there's also combustion of an element when you're burning something such as a metal. You're just going to get EO. And that's not balanced. Here we go. Here we go. Here's an example of combustion of an element. Okay, so now we're going to predict products using the different types of reaction. Now since these two are coming together, we know that this is a synthesis or a combination reaction. In fact, all of these on this one page are synthesis or combination reactions. We've done stuff like this before. Now what you have to be aware of, you cannot just add these two together and do that. You have to look at the charges first. So the charge here is plus. The charge of iodine, don't look at the charge of I2, look at the charge of iodine. And we could even just forget that for now. It's minus. And when they come together, they're just like this, NaI. We'll have to bring that back. Now we balance it. So you may ask, hey, where does that 2 go, though? Well, it's when we balance it, so we'll balance it with 2 Na there and a 2 here. And that is balanced. And so we have all of these in solution. So that is our product of sodium plus iodine. Now what about this next one? Magnesium has a charge of 2 plus. Let's just look at the charge of fluorine. That's minus. They will come together as MgF2. Let's bring this back now so we can balance it. Well, FMg, well, okay, well, there we go. It's already balanced. That works out. All right, let's look at another combination or synthesis reaction. Ba, barium, has a charge of 2 plus as well. Oxygen, let's just look, oxygen alone is a charge of 2 minus. They come together as BaO, BaO. Let's now balance it by revealing that 2 again. So there were 2 oxygen, so we put a 2 there, and then a 2 here. So far these have been really easy to balance. Now let's look at this last combination synthesis reaction. Li is a charge of plus. Bromine has a charge of minus. We put them together, LiBr. Now we'll balance it. So we had 2 bromines. We put a 2 here. And now we have 2 lithiums. So that's balanced there. Those were pretty easy to balance. So when you're predicting products, when you're bringing things together, you have to look at what the individual atoms are. We don't really care about these until the very end where we balance. So just kind of block these subscripts out and do it like you've done 100 times before. Put them together. Then, when it's time to balance, reveal that again and go ahead and balance. Okay, now we're going to predict these products. The only thing that can happen here, because there's just one compound, this has to be decomposition. Nothing can happen except they can break down. Now, knowing what products they can break down to is probably the tricky part. But once you know the basic rules, and we should know most of these rules, is that we're not going to just break it down into N plus H3. We have to know that this is a nonmetal and this is a nonmetal. Nonmetals must exist bonded to something else, either diatomic or with something else. All nonmetals, except, of course, for noble gases. Noble gases can be off by themselves, such as helium we can have off by itself. neon, argon. But the thing is, they're not going to be involved in any sort of compound anyway, so we're never going to see these, basically, as far as any sort of decomposition reaction. Now, if we have to know that nitrogen, when nitrogen is, we're going to get nitrogen and hydrogen. We know that for sure because that's all that's there. But nitrogen is going to have to be diatomic. Nitrogen can't be by itself. Now hydrogen is also diatomic. It cannot be by itself. So these are the two products. Now we must go balance it. So when you see something like this and it's part of a decomposition reaction, they're going to be diatomic. Let's balance this. Let's just go with 3 here. And the reason I'm doing that is because I know 3 and 2, I want that lowest common multiple or highest common denominator. I can never remember, but it has to be 6 here. So that's going to be 6 here. And then watch here, I put a 2, and that balances everything else out. So the next one, we're going to break down, decompose into H2, of course, or H and S. Now H just has to be diatomic as well, as does sulfur as non-metal. Now let's just balance it. H is already balanced. Sulfur, though, okay, sulfur is balanced, and to balance the hydrogens, we put a 2 there. Pretty easy. Now the next one is a good example. We have calcium and oxygen, so that's what that decomposes to. Now oxygen has to be diatomic. It can't just exist by itself, so it's O2. What about calcium? Well, calcium is a metal, so calcium can be by itself. So we can leave calcium. Calcium's a metal. Now let's just balance. We need a 2 here to balance the O, and then we'll put a 2 here to balance the calcium. So far, pretty easy. What about silver oxide? Excuse me, mercury oxide. Mercury and oxygen. Oxygen has to be diatomic. Mercury is a metal, so we can leave it. Now we just have to balance. We'll put a 2 here and a 2 here. All good.